This is the Almost Timely newsletter for the week of September 29th, 2024. Content authenticity statement. 100% of this week's newsletter was generated by me, the human. You will see AI outputs and usage when we get to that section in the opening. There's a link at the top of the newsletter to understand why this kind of disclosure is important. This week's big plug, I fixed the inbound link. Apologies for that. I sent out a follow-up email on Tuesday. Last week's newsletter had the wrong link for the inbound masterclass that I taught on generative AI and building a data-driven customer journey. So sorry about that. That was completely my screw up. All right. What's on my mind this week? Small language models and generative AI. Small is the new large. Okay, it's maybe a bit of a stretch, but there's a logic to this statement. Large language models, like the ones that power tools such as ChatGPT, have historically been gigantic pieces of software that require entire data centers and even nuclear reactors to power. I saw Microsoft is investing to bring 3 Mile Island, the reactor complex that had a partial meltdown in 1979, back online because they need the electricity. We're just not generating enough electricity to power all this generative AI stuff. Large language models, the really big foundation models, consume crazy amounts of electricity and fresh water. They use that for cooling to keep massive clusters of computers operating. Since the beginning of the generative AI era, there has been a parallel development of open models, which are sometimes called local AI, private AI, open weights models, etc. Clearly, marketing has not been involved in this whole naming scheme. And these models are smaller, but still very capable of doing many generative AI tasks. This past week, we saw another entrant in the small models field, Meta's Llama 3.2, 1B, and 3B models. Again, you can tell marketers not involved here. This joins a family of models like Gemma 2, FEEP 3.5, Quen 2.5, and others. These models, which are all under 5 billion parameters, are small, lightweight, very fast, and consume far fewer resources than their massive siblings like GPT-4o and o1, etc. So let's break down what this all means, why you might care and want to implement it, and how to decide what to use small language models for. Part 1, model sizes. To get a sense of how to think about language models and their sizes, we should talk about how they're made. All language models and their multimodal cousins are built using massive amounts of data, typically scraped from the internet, with or without people's permission, and other public and private data sources. Model capabilities are measured in the number of word pieces, called tokens, that are used to build them. More is better, but increases the cost of building the model. That's why when you look at who makes these models, you see the usual list of suspects like Google and Microsoft and Meta as the originator of many models, because they've got the budget, the compute capacity, and the facilities to build these things. Meta was talking about have got 100,000 GPUs. Bear in mind, a single GPU uses about 700 watts of electricity and generates a lot of heat. They got 100,000 of these things churning away, just working on a model. And rumor has it all the other big players are in the same league. 100,000, 200,000 GPUs, massive, massive scale. Meta's Llama 3 family of models are trained on 15 trillion tokens. To give you a sense of how much text that is, that's about 12 trillion words. That is a bookshelf of text-only books like this that stretches around the equator twice. It's a huge amount of text. This whole thing here, this is 800,000 words. It's about 1.2 million tokens. That's it, right? That's not a lot. Once a big tech company makes a model by digesting all those tokens down into statistical relationships, they then make various size versions of the model labeled by the number of parameters. Parameters are the statistical relationships between tokens. There's a clear statistical relationship between word pieces observed when models are made. For example, can you predict the next word in these text sequences? Number 1, I pledge allegiance to the. What's the word that comes after? Number 2, God save the. What's the word that comes next? There's a good chance you can predict these if you're American or British or familiar with American or British cultures. The probability is nearly 100% in the first sequence of words for the next word to be the word flag. I pledge allegiance to the flag is the most common completion for that, right? It's probably not rutabaga. And it's a mix of probabilities in the second sequence. Could be king or queen, depending on the data set and how recent it is. Either way, the relationship between each of the words is a parameter. When we say a model has 1 billion parameters, 3 billion parameters, we're talking about the number of statistical relationships it knows about. Here's a concrete example using hair color. I was at Target earlier today. A small model, if you gave it the word blonde, might come up with like a few associations because it was trained on a very small amount of data, right? A big model, if you gave it the word blonde, it might come up with an entire shelf full of products if it was trained on that. The bigger the model in terms of the number of tokens it was trained on, the more associations it has for every word you ask it. If these models were libraries, a small model might be like a little community library or those little tiny libraries on the side of the road. A big model might be a library like the Boston Public Library or the British Library in London. They have way more knowledge to draw on because they have a greater number of statistical associations. So, don't we want the biggest number of parameters all the time, the biggest models? No. More parameters means the model has more associations, more variety, more knowledge, but is bigger. It consumes more resources and is slower. More memory, more processing power, more electricity. The bigger a model is, the more resources it consumes, and the slower it works, and the more horsepower you need to throw at it, consuming more resources. Models under 5 billion parameters can run on modern day high end smartphones, right? Models under 2 billion parameters can run on most smartphones, albeit not quickly for low end phones. But your phone consumes way less power than a data center. So here's how these two metrics, training data tokens and parameters, interact. The more training tokens that went in, the more robust the model is compared to a similar size model with less training data. That's why a model like Meta's Llama is so incredibly smart for its size. Even though it has a small number of parameters, it had a huge training data set, and thus its performance is better than another model of a similar size. Going back to our hair color example, if your training data set was a small shelf of products, your knowledge would be limited to what you saw, and you wouldn't have the vocabulary to describe exotic hair colors. If your training data set was a manufacturing facility for hair coloring, then you've probably seen every combination of hair color name. And even if your vocabulary is relatively small, it probably has more range of knowledge about those hair colors. Same thing, imagine you're at the home improvement store. Yeah, a small model that wasn't trained on much. You say the word red, it might come with like 3 little paint swatches in the paint section. A model that was trained on a lot of data, even if the model's small, we say red, might see a shelf of those little paint swatches that are all different shades of red. The more training data that you started with that's good quality, the better the model is going to be, even at a small size. Part 2, what small models are and are not good at. Let's extend our analogy of the model size as a conceptual library. A small model has a small number of books. A large model has a large number of books. Because the small model has less knowledge, it's less fluent, especially when it comes to generation. As an aside, the irony is that despite us calling it generative AI, generation is what most language image models are least good at. There are 6 major use case categories of generative AI: generation, extraction, summarization, rewriting, classification, and question answering. Here are my 3 rules for working with models of any size. The smaller the model, the more likely it is to make things up, to hallucinate, all other things being equal. The smaller the model, the more data you need to bring into the conversation. The smaller the model, the more granular you need to make the task. Models' reasoning capabilities declines with size. If you follow these rules, small models can be just as capable as large ones for a wide variety of tasks. Which tasks depends on how much data you're bringing. In order, these are the tasks small language models excel at from best to worst. Extraction. Super easy for a language model to return an identified portion of data. Summarization. Pretty easy for a language model to boil down existing text. Rewriting. Pretty easy for a language model to rewrite things like writing style and tone as long as you provide solid examples and strong prompts. Small models do really start to suffer issues with things like language translation. They're just not as good at it because there's fewer books in the library. Classification depends on the complexity of the classification. Small models may not be able to think things through for complex classification. Question answering, depending on the complexity of the question, small models may not be able to stitch together complex knowledge. And generation. Absent you providing data, small models will happily hallucinate all kinds of things. By keeping these guidelines and rules in mind, you'll be able to decide what tasks you do and don't want to hand off to small models. Part 3, choosing a model. We're going to have more documentation coming very soon on the Trust Insights website about this. But for now, here's a good rule of thumb. A lot of rules of thumb today. Every computer has 3 major resources: CPU power, regular memory, called RAM, and video memory, VRAM. For maximum generative AI performance, you need as much VRAM as possible, video RAM. For people with M series Macs, the M1 Max, the MacBook Pro, and Mac Studio M2, whatever your max total memory is, divide it by half, and that's effectively how much VRAM you have, give or take. So if you have a Mac Studio with 64 gig of memory, you have 32 gig of VRAM, effectively. For people with Windows computers, your computer should be able to tell you how much VRAM you have. I haven't used Windows in a really long time. I know it's available in the display settings somewhere in the labyrinth that is Windows settings. If you can play Call of Duty or World of Warcraft or whatever at full resolution with no issues, you probably have a lot. The rule of thumb is this: whatever your VRAM is, you can run a model that's 1.5 times that size in billions of parameters. For example, if you have 4 gigabytes of VRAM, you can run a model up to 6 billion parameters with good sized conversational memory, the ability for it to remember what you're talking about. If you have 16 gig, you can run a model up to 24 billion parameters. If you have 64 gigabytes RAM, I envy you. You can run a model up to 96 billion parameters. If you have 512 gigabytes of VRAM, you have a server cluster in your house, and you probably have an electric bill with a lot of digits before the decimal place. But you can pretty much run whatever you want. That would be companies setting up a server for their employees to use. There are more complex and arcane rules for selecting a model, like quantization levels, model formats, etc. There's a bunch of arcane things, but that's for another time. The above rule of thumb is generally a safe one. Whatever VRAM you have, multiply times 1.5, and that's roughly the model size you can get and run safely on that hardware. Now, here's the challenging part. What kind of small language model might you want to get? Here's where this is just going to get really tricky. As of yesterday, there are, and I'll bring this up here on screen for those not watching. There are over 1 million different models to choose from on Hugging Face, which is sort of the world's largest repository of open models. 1 million. Why? Because with open models, people can download a foundational model like Llama 3.2 and customize it to their needs. Some people might customize it to be super good at programming, but bad at writing. Other people might make a version that's great at writing fiction, but terrible at writing nonfiction. Generally speaking, you want to use models, foundation models to start, models from the big companies like Meta, Mistral, IBM, Google, etc., because those models will be as versatile as they can be in a small package. Part 4, prompting small models. We're all used to writing great, highly detailed prompts for big models like Google Gemini and GPT-4o, and those complex multi-step prompts do well in big models. It's what we teach in the Generative AI for Marketers course, in my lectures and workshops and keynotes. That's not applicable to small models. Those big prompts don't work as well in small models because the small models just don't have the reasoning capabilities of larger models. To accomplish similar tasks, we need to break up our big model prompts into the individual steps they're composed of, and either manually or programmatically, meaning you write code, feed them to our small language models. For example, suppose you have a multi-page prompt for generating a blog post in your writing style that contains examples and instructions, a scoring mechanism, all sorts of really cool stuff. A big model like Gemini Pro can run it as is. It'll do fine. A small model like Gemma 2 will need you to break it into individual pieces. First, telling it what the writing style is and waiting for it to respond. And then what a good example is and a bad example is, each individually, and waiting for it to respond. Then the instructions, waiting for it to respond. Then the scoring mechanism, waiting for it to respond. Each piece has to be executed separately because it's not that smart. And during development, when you're building a set of prompts for small language models, you absolutely should be inspecting it to make sure that it's doing what it's supposed to do, because small language models don't have as good of reasoning capability. Small models also tend to have smaller conversational memories. That is, they can remember fewer things during a conversation session. Gemini Pro, for example, as a giant model, can remember two of these in a conversation, 1.5 million words effectively. That's how much it can remember in a single conversation when you're chatting with it. Meta's Llama 3.2, only about 80,000 words, right? Length of a business book. So it's not as capable as a big model, obvious reasons. It will run slowly if you try and put the entire book in all at once. By breaking down your prompts into tiny pieces and feeding each piece into the model, you'll take advantage of what small models are capable of without overwhelming them or confusing them. Additionally, small models will have less of a vocabulary than larger models. So, one of the first things you will need to do is ask the model to help convert your existing prompts and rewrite them to work best with it. Imagine taking a librarian out of the Boston Public Library. They know where everything is in the Boston Public Library. You can't just say, "Hey, you're now in the Mary Muser Library in Pennsylvania." Boston Public Librarian, where's this book? They're like, I have no idea. I've never been here before. You would have to retrain the librarian, say, okay, well, now you're in this library, and here's a much smaller catalog of books. Now, for folks who are highly technical, um, there are frameworks like DSPy that can help you automate the process of converting your prompts, but that's vast overkill for most tasks. One way around the shorter conversational memory of small models is to provide them with extra data in a custom database. This is a technique known as retrieval augmented generation, where you take your data, encode it in a format that the models can read and understand, then you make that database available to the model. If we think of a model like a library, retrieval augmented generation is like building a new wing on a library. The librarian still has the same general task, but now has more resources to answer questions. Let's take a look at what a small model would look like. So I'm going to switch over here. Okay, so let's go ahead and take a look at this. I'm going to be using anything LLM. The interface should look very familiar. This is very much like ChatGPT. It's an open source piece of software. This is the client side. There's a server side as well, and the server side is looks like this. This is cobol.cpp. Is a server that connects the model, makes it available, just like a web server connects to web pages and makes web pages available to browsers. I'm going to go ahead and we're going to start with something very simple. We're going to start with what do you know about the consulting firm Trust Insights at trustinsights.ai? And we'll see what it knows about this. So this is just asking the model itself. And the model comes back with, it's a global research and analytics firm, strong presence in various industries, finance, retail, and healthcare. This is okay. This is not great. This is Llama's 3 billion parameter model. And it's kind of it's making stuff up, essentially. It's hallucinating. So I could say, who is the CEO of Trust Insights? Let's ask. And it says, I don't know, which is interesting because previous versions of Llama would make something up. Now it's got a decent, it knows enough to basically say, I can't help you, as opposed to lying, which is a major improvement. Now let's talk about how would you deal with this situation where you want to use this tool, this piece of software, but it doesn't know any information. Let's start a new thread. I'm going to go to my upload a document here, and I'm going to start putting in links. So I'm going to put in a link to the Trust Insights about page, and I'll put in a link to our services page. And I will go into our, where's our team page here? There's our team page. I'll take these documents and make them available to the chat. Now, if I close this, and I'm in now a new thread, And I will ask it, what do you know about the consulting firm Trust Insights at trustinsights.ai? Let's see what it says now. This is much better, right? This is data. Essentially, it's summarizing from our website. We're an IBM registered business partner, a minority and women-owned business. We have these clients, etc. Really, this is much better. Now I can say, who is the CEO of Trust Insights? Katie Rivera is the CEO of Trust Insights, right? Which is correct. Now, on the back end, you can see what's happening is the model is essentially trying to figure out what word should come next in its responses. It will take the prompt, then it will go into its document store that we gave it, the retrieval augmented generation, and now it can answer questions from this. And I could say, summarize the services that Trust Insights offers. And here's a bunch of things that it knows now thanks to us providing the data. So this is where small language models are really helpful because we can now take data we have, give it to them, and they give us good answers. But we have to provide the data. We have to be the ones to bring the data to the party. And again, the smaller the model, the more data you have to bring. This thing really doesn't know very much about anything, has a very superficial sort of view of the world. What it does know how to do is use language. So if we provide the data and it provides language skills, we can do very well. This thing will work very, very well for us. So to wrap up, why small models? With all these trade-offs, like you got to bring your own data, why would we use small models? I did a talk at MACON 2024, links at the top of the newsletter. I would just strongly encourage you to watch it because we explored all this in detail. But the short version is small models that you run on your hardware are private. Data doesn't go anywhere. Low power, good for sustainability, and always available. I've used models on my laptop during flights without Wi-Fi and had the power of generative AI ready to help me summarize stuff, extract stuff, and so on and so forth, whenever I needed it, especially with a decent setup like what I've got running on my computer. These llama models, they can run on your phone, and that that's really important. And the reason it's really important is because this opens up doors of access. A person might want access to basic generative AI for summarization, but not using third-party services. Maybe you've got uh, uh, some documents that you need to have explained or a document you want summarized, and it's very confidential stuff. You don't want that in the hands of somebody else. A small model will let you do this on your own hardware with no internet access. For places with fewer resources like developing regions, this makes generative AI available at no cost besides powering your phone, right? If you can run it on an iPhone, that levels the playing field even more, especially for people who maybe can't afford, 20, 30, $40 a month for online services, but still want to be able to use generative AI. That's why it's such a big deal because these models are small, they're fast, they open up doors of access to others to make generative AI work for everyone. The reality is, for many AI tasks, like write this email in a way that won't get me fired, you don't need a big foundation model that chews up huge amounts of natural resources and energy. It's like taking a Harrier to the grocery store when a bicycle will do perfectly fine. If we want generative AI to not only live up to the hype, but also to not cause more harm than good, we need to begin looking at how to choose the right size AI for the task at hand. Through tools like local models, open models, we'll save a lot of energy that way, enhance privacy, still get the jobs done we want AI to do. All right. What else happened this week? In the on the blog and on the channel, I did a bunch of different posts answering some questions. One that was asked a lot at Maycom was, why can't AI make a nice slide deck? And talk about the reasons why. Also, Katie and I wrapped up our 4-part series on responsible AI with the implementation of responsible AI. So go check that out. Let's see what we got for jobs this week. We have AI trainer at Brado, analytics business development leader at Capgemini, analytics product owner at Nexus Sleep, analytics something at LinkedIn, analytics, artificial intelligence researcher at Lumicity, associate director of data strategy at W Promote, business intelligence partner at Randstad Enterprise, career SaaS health tech at Prompt, conversation bot engineer at Quantify, data engineer for GA4 at Horizontal Talent, generative AI training data set consultant at TELUS Digital, head of insurance operations at Headway, insights associate Sensor Tower, RevOps manager at Zano, senior analyst at Dentsu, and senior SEO strategist at Jobot. So lots and lots of stuff coming up there in terms of jobs. It is interesting right now. The market is kind of in a weird spot. On the one hand, there's a lot of job openings that people are having trouble filling, but for whatever reason, are just not connecting job seekers with the folks who are hiring. And I'm not sure why that is. Upcoming events. Let's see. I believe the next major event I have is Marketing Props B2B Forum here in Boston in just about a month's time. So if you're going to be at that, drop a line and say hi. If I'm doing a workshop with Katie. We're going to be using generative AI to do B2B marketing measurement best practices. And then I'm going to be doing a talk on B2B marketing prompt engineering for generative AI, which that one will be a lot of fun. I'm debating with that one. Should I do slides or should we just do a live? Let's get jamming. I'm leaning towards doing something live because I want people to see how capable these tools are, and a bunch of slides just kind of boring. Anyway, that's going to do it for this week's newsletter. Thank you as always for watching it. I hope that you found it useful, and I look forward to hearing from you soon. Take care. If you enjoyed this video, please hit the like button. Subscribe to my channel if you haven't already. And if you want to know when new videos are available, hit the bell button to be notified as soon as new content is live.